Living in Placer County, it's hard to imagine that there are over 1 billion people suffering from an infectious disease that leaves them feeling weak, anemic, and with impaired cognitive and physical development. It affects millions of grade school-aged children today, and we need researchers to find a way to eradicate it. The problem is called intestinal parasites. In tropical and subtropical areas, including sub-Saharan Africa, China, East Asia, and Central America, roundworms infect millions of people. The World Health Organization estimates that over 270 million preschool-aged children and over 600 million grade school-aged children suffer from intestinal parasites. It makes it difficult to gain proper nourishment and frequently causes immune problems, stomach bloating, abdominal pain, and a lot of other awful complications. This negatively affects people's quality of life. This is our hero, Jillian Sesar. She's a recent PhD graduate from UC San Diego, and she and her fellow lab partners have been doing research for almost a decade to solve this problem. We talked with Jillian about the problems that intestinal parasites cause.
The people that are mostly infected are mostly people in third world countries. So they affect some of the poorest people in the world. So they mostly affect children and pregnant women. So they cause things like malnutrition, and in children you see a lot of stunted growth, reduced cognition, reduced appetite, and then a lot of immune defects. So vaccines aren't as effective, and then some other further complications when there's co-infections with other diseases such as HIV or tuberculosis at the same time. So when the worms grow up, if you think of worm life cycle, if you will, they start as larvae and they're free living. So that means they're mostly just roaming around in soil or in feces. And then they become a larvae, and that's the point they can actually infect a host. So they can become infectious larvae. And in the case of hookworms are skin penetrators. So all it takes is someone to put your hand on something or to step if you're walking barefoot to get infected. And then the worms will mature into adults, and that's when they hook onto the intestines and they become blood feeders. And then they'll excrete eggs that shed out in the feces, and that cycle starts all over again.
Jillian was studying microbiology at UC San Diego and was inspired to work on finding a cure for this problem.
So at the beginning of grad school, one of the things they do is, for my year, they had all the faculty come in, and faculty all gave these little 5-minute lectures on what their lab does. And the idea was to introduce you to all these different things that you may not know existed, because I didn't even know this was a field that existed. And so it was interesting. So I did a little 6-week rotation in the lab, and it's just supposed to get you familiar with the different labs. You do a couple 6-week rotations just to learn and see if you like it. And it was this whole other field that was really fascinating. And I guess that was about, now it was about 7 years ago that it was really interesting to me. I really liked the idea of working in tropical medicine and doing science that could directly impact people in the world, I guess, versus just very basic science. I like the duality of it.
This kind of work takes years and years to complete. Jillian is part of a team called the Arroyan Lab, which is named after her advisor, Rafi Arroyan. She met Dr. Arroyan during her graduate program at UC San Diego.
It was one of the faculty. His name was Rafi Arroyan. He was my advisor during grad school. It was his lab that actively conducted the research. So he gave the little talk, and he's a very engaging, really passionate scientist. So he kind of sucked me in with this idea, and I just learned more and kept getting kind of more captivated by working in this field and addressing this issue.
The team at the Arroyan Lab proposed a theory on how to solve the problem, using proteins produced by a common bacteria called Bacillus thuringiensis, or BT. BT has never been used in this therapeutic way before.
Crystal proteins are naturally produced. There's a soil bacteria called Bacillus thuringiensis, and it's pretty much found everywhere. It's not fancy or new or anything. It's a soil-dwelling bacteria. So when these proteins grow, they naturally sporulate. It's just part of the process, and they produce a spore and a crystal. And so in the lab, I can grow the protein up. I can grow the bacteria up. And then basically I can harvest out the crystal part only. So I can basically grow it up, wash it to clean it of the media that I grew it in. And then there's a procedure we use to pull the crystal away from the spore, and the crystal basically is my protein that I work with. So the one worm I worked with the most was called Angiospermia salonicum, which was a hookworm. And that actually is one of the few worms we have in the lab that can actually actively infect humans. So we tested the protein in a couple different ways. I would be able to take worms. I could take eggs, like we would isolate feces and isolate the eggs from the feces, and then I could put the protein in little wells with the eggs and compare it to what happens if you didn't have the protein in the wells. You can see a very big difference. So this protein, when it targets the worms, you can see the worms are smaller, they're reduced in color, they're pale, their movement stops, and they do eventually die.
Several hurdles still remain, though. The product must be inexpensive, easy to administer, and resolve the problem with a single dose, but the team is still hopeful.
I think it has a lot of potential and a lot of possibility. There's so many branches and avenues that they were working on in order to address this problem, and everyone's so motivated, and we've only started to grow with ideas that I think this is it could be really neat to watch it in the next couple of years grow and develop, and I think maybe, become a really good candidate for a new way to address the problem of parasitic worms. So I definitely believe in it for sure.
We think that the work Jillian Sesar has done to show that cryocrystals can be used to kill intestinal parasites in humans will provide a better quality of life for millions of impoverished people worldwide. This is why we chose her as our hero for this project. Thank you for watching.